Alright, today's question is flood fill, and it's very similar to another question that we've done before, which is number of islands. So if you just want a hint, check out that solution first, and then see if you can apply it to this problem. In this problem, they give us an image, and this image, we can sort of think of it like this. So the numbers are our pictures, and what they want us to do is they want us to flood fill a coordinate point. So in this case, the example is 1, 1. So we go to row 1 and column 1, and we want to flood fill it with green. So flood filling means that everything that is surrounding it with the same color gets all filled up with green. So if you're somehow connected to this main body, then you're all turning to green. Now notice here that this blue didn't turn into green because it was protected by this orange, these two orange here. So there was nothing around it that turned green. Okay. So, flood fill is you turn it green if you're the same color and you're connected. So how do we solve this? We're going to do this recursively. So we want to go up, down, left, and right in no particular order. So all we have to do is when we come in, first we want to check, is it the color that we want to replace? So right now the color that we want to replace is the original color at 1, 1, which is this blue color. So 1, 1 is of course blue, so we replace it. And then we go up. So we do our first step, we go up, and then in here, it's also blue, so we can fill it with green. And then now, because it's recursion, this also tries to go up, at which point we're outside of the map, so this is cancelled. And now we finish the up route, so now we go down. So now we attempt to go down, but as you go down, you can see here that this is no longer our target color blue, so this will also get cancelled. Now we go left, and then this is a target, so we can fill it with green. And then here we also go up, which gets cancelled, and now we go down. This gets filled up, tries to go up, but because it's no longer blue, this gets cancelled, so we go down. And then from here, the same thing happens, go up, gets cancelled, down is outside of the map, left is outside of the map, right is not the color that we want, so it's also cancelled. So now we come back to here, which was in the process of going down. So we check left, which is outside the map, and we check right, which is no longer blue. So this is also finished. And it kind of just spirals back up and then finishes with this going up, left, right, down, and then comes back here, and then this going not a blue and not a blue, and then we finally finish where we started. Okay, so that brings us to actually an edge case. So right now, we're assuming when we have something like this, so when we have blue to blue, and we're trying to filling it with green. So, all right, let's use orange. So you try and fill it up with orange, and then we go here, and then we fill this with orange, and then we go back. So this gets canceled because it's no longer blue, so we don't end up in this infinite loop. But what if they didn't change the color? So what if they asked us to flood fill, so fill with blue itself? Then we would just fill with blue, we'd go here, fill with blue, we'd go back, it's blue, so we need to replace it with blue, so we do that, and then we start to get into this infinite loop here. So this case is very simple to handle. If we try and fill with our own color, we will just return the unmodified image, because that is the same thing as doing nothing. Okay, so with this in mind, let's try implementing it. Okay, so let's handle our edge case first, which is if image at sr@c is equal to our new color, we can just return image. So flooding your own color is meaningless. Okay. Now we will do our recursion. So we'll fill our image at this row, at this column, with this new color. But notice that once we fill in this new color, we'll lose track of the old color. So what we want to do is we should give our recursion our original color. So this will be image sr sc. So here's how we'll use it. So we have our private void fill, takes in our image, our row and our column, our original color, and our new color. So first we can check the bounds. So if this is outside of our image, then we don't care about it. So if row is less than 0, or row is greater than or equal to image.length, or column is less than 0, or column is greater than or equal to image at 0.length, then we can return, because this is outside of the image. So if that's the case, we can just return. The other case that we can do is if our image at this row and column, so now we can use the row and column because we did our bounds check here to make sure that it's valid. So if image row and column does not equal the original color, then this is not a pixel that we should be flood filling. So here we can also return. Okay, so otherwise this is definitely a pixel we should be flood filling, so we'll set it to our new color. And then at this point, we'll do our up, down, left, right. So it'll be fill, image, so up will be row -1. And now we go down. So down will be +1. We'll go left, so that will be -1. And then we'll go right. Okay, and then at the end of flood filling, we will return our modified image back to the caller. All right, let's give this a go. Cool. So as you can see, worst case, what we have to do is we'll have to flood fill the whole image. So if we have to replace every single value, then that means we look through every single value. So this means this has a runtime of O of n. And you can see here, we never visit a single pixel, more than twice. Maybe we visit it one more time because we do this going back thing, but then we cancel it when we realize that it's no longer the original color. So that means at most we would visit the same pixel twice, but in total that's still O of n. Okay, so what you could do is you could do the bounds checking here. So you can do like if row is row -1 is greater than or equal to 0, and the image at row -1 column equals the original color, then do this fill. So that would guarantee you that you would only fill what you need to, so worst case is O of n. So either way, both cases are worst case O of n. All right, that's the end of today, and I'll see you on the next one.